Welcome back. Today we are dealing with types of SADs. So we said there are two types. We have pure SADs and mixed SADs. So we start with pure SADs. Pure SADs are SADs with 1 as a coefficient. Now what's the meaning of this word coefficient? If you are given a variable x and preceding it there is 2. So this 2 is called the coefficient of x. Now we are dealing with SADs. When you have a SAD written in the form nth root of a, and here we have m. So this m is called the coefficient of this SAD. So when you have a variable x and there is nothing written here, always you should know that there is 1 as a coefficient. We know that 1 times x we still get x, so it is as good as not writing it. So when you have a SAD, nth root over a, we should know that if there is nothing written here, there is an invisible 1. Coming back to our definition, we are saying pure SADs are SADs with 1 as a coefficient. As you can see here, there is an invisible 1, and here there is an invisible 1. So these two are called pure SADs. Now let's see, what are mixed SADs? Mixed SADs are SADs with a coefficient less than or greater than 1. So we have examples here. We have 2 root 3, 4 root 7, 20 root 6, cube root of 6. When you look at this one is greater than 1, this one is greater than 1, this one is greater than 1. So these coefficients are all greater than 1. Therefore, all these ones given here are called mixed SADs. Why? Because the coefficients are all greater than 1. There is something very interesting here. It is very possible to convert SADs from pure to mixed and also from mixed to pure. As you have noticed, yesterday we didn't solve anything, but today we are going to solve a little bit. It is not really hard. Let's see how we can solve this. Question. This is how questions come in an exam. Convert the following SADs from mixed to pure. Okay, so we are given a mixed SAD here. The coefficient is greater than 1. Yes. So we have 2 root 3. Okay, how do we convert this one to a pure SAD? So what we are going to do is this. We are going to write this radical sign, and we use this small formula here. So we get the radicand given. We are given 3 here, so we get the same 3, we write it under here, times the coefficient given. So we get this 2, put it here, and this coefficient will be raised to the power index. What is our index? Yesterday we said here there is always an invisible 2. So if there is nothing given here, it means that there is an invisible 2. So this will be 3 times 2, which is this one, to the power 2, which is gotten from this part here. So we know that 2 to the power 2 is giving us 4. So 4 times 3 will give us 12. So this 12 has a coefficient of 1. Therefore, it is a pure SAD. Let's look at another one. We have 3 and the square root of 5. Remember, you write the radical sign. This 5 remains the way it is, times the coefficient, which is 3, and raised to the power. What is our index? Our index here is an invisible 2, so you raise it to the power 2. 3 to the power 2 is giving us 9. 9 times 5, we get 45. So the square root of 45, we know the coefficient is 1. Therefore, it is a pure SAD. Okay, let's look at 2 more examples under the same. How do we convert this one? This is a mixed SAD because the coefficient is greater than 1. So what we do, we write the radical sign together with its index. So we have the cube root of, this 2 remains the same 2, times this one goes inside and raise it to the power index here. So we have 2, this 2 here, times this 5 to the power, what is our index? 3. So 5 to the power 3 is 125. When you multiply by 2, we get the cube root of 250, which is a pure SAD. Okay, let's look at one more last example. Under the same, we have 2 and the fourth root of 4. How do we convert this mixed side to a pure side? So this, we write the radical sign together with its index, which is this one here. This 4 remains where it is, but this 2 goes inside. When it goes inside, it will carry the power, which is our index. So this is 2 to the power 4. 2 to the power 4 is 16. 16 times 4, we get 64. So we have the fourth root of 64. What is the coefficient? The coefficient is 1, therefore it is a pure side. So this is how we convert mixed sides to pure sides. Alright, now let's take a break. Go through the video and then try to solve the following questions. So this is exactly how questions come under this topic. Convert the following mixed sides to pure sides. So try to solve these ones. I'm giving you 1 minute. Try to solve these questions here so that we move to the other subtopic. Alright, that was perfect. Now, let's see. We need to move on to the next one. Alright, let's move on to the next subtopic. We were converting sides from mixed to pure. Now this time around, we are converting pure sides to mixed sides. This is very simple. So we are converting them in their simplest terms. We have the first one here. Convert fourth root of 64 to a mixed side. A mixed side. We know that this one is a pure side. Now we need to convert this one to a pure side. Now what do you do? Here you ask yourself, is there any perfect fourth root that can go into 64? Yes, it is 16. How many times can 16 go into 64? 4. So this is 4 times 16. We haven't changed anything here. It will still give us 64. Now what is the perfect fourth root of 16? It is 2. So we get this 2 will go outside. Why? Because we have found its perfect square root, or its perfect fourth root. What remains inside is 4. Okay, so since this one has gone outside, 2. Okay, the fourth root of 16 is 2. We put it outside, and what remains? We have the fourth root over 4. So this one is a mixed side. Why? Because the coefficient is greater than 1. Okay, let's look at another one. The cube root of 250. Ask yourself a question. Is there any perfect cube root that can go into 250? Yes. So that is 125. What is the cube root of 125? It is 5. So you take it outside. What remains? The cube root over 2. So this is a mixed side. Alright. We go to the other one. We have 2 more examples. We have the square root of 45. Any perfect square that can go into 45 without leaving a remainder? Yes, it's 9. What is the square root of 9? 3 goes outside. What remains under a square root? 5. Okay. The fourth one. The fourth one, yes. The square root of 12. Any perfect square that can go into 12? 4. How many times can 4 go into 12? 3. What is the square root of 4? 2. So it goes outside. What remains? The square root over 3. So this is a mixed side. So this is how we convert pure sides to mixed sides. Alright, let's take another break. Solve the following questions. Convert the following pure sides to mixed sides in their simplest form. So we have these ones, we have this one, this one, this one, this one, and that one. So altogether we have 5 of them. Oops! Have you found out something? You find that the answer to the first exercise I gave you, this one here, is this one here. So question 1 of exercise 2, let's call this exercise 2. So find question 1 of exercise 2 is the answer to question 1 of exercise number 1. We can call this one exercise number 1. So we find that question 2 of exercise 2 is the answer to question 2 of exercise 1. Question 3 of exercise 2 is the answer to question 3 of exercise 1. Question 4 of exercise 2 is the answer to question 4 of exercise 1, and question 5 of exercise 2 is the answer to question 5 of exercise 1. So today we are going to end here. Make sure you practice before you sleep. Make sure you know how to solve these ones. Then tomorrow we are going to do addition and subtraction of SADs. Have a good day.